All right, so we're going to establish Bernoulli's inequality. So if 1 plus a is bigger than 0, then 1 plus a to the n is bigger than or equal to 1 plus n times a for every natural number n bigger than or equal to 1. All right, so we're going to do a proof by a principle of mathematical induction. So we're going to do our base step. So we're going to consider P of 1. All right, so that's just 1 plus a to the 1 is bigger than or equal to 1 plus 1 times a. I think that's clearly true, right? Because that's going to be 1 plus a is bigger than or equal to 1 plus a, right? So the inequality holds, right? So let's go ahead and do our induction step. Suppose P of k is true. Thus, we have 1 plus a to the k, right, is going to be bigger than or equal to 1 plus ka, right? Okay, so now let's go ahead and consider uh, 1 plus a to the k plus 1. We know this is equal to 1 plus a to the k times 1 plus a. And from our assumption, we know this is bigger than or equal to, so 1 plus a to the k is bigger than 1 plus ka times 1 plus a. And then we can go ahead and do, this will be 1 plus a plus ka plus ka squared, right? And let's see, we need to be 1 plus, so we know this is equal to 1 plus. So we have k plus 1 times a, and then plus ka squared. And then, of course, a squared for any real number a, for any number a, we know a squared is going to be positive, right? And we know k is a natural number, so ka squared is positive. So we know surely this is bigger than, right? Bigger than or equal to 1 plus k plus 1 times a, which is what we wanted to show. We wanted to show that 1 plus a to the k plus 1 is bigger than or equal to 1 plus k plus 1 times a. And of course, if we have this, right, from the inductive step, we know 1 plus k plus 1 times a, because we factored out that a here, plus ka squared is definitely going to be bigger than or equal to 1 plus k plus 1 times a, this piece, right? Thus, we have 1 plus a, k plus 1, is bigger than or equal to 1 plus k plus 1 times a, right? Therefore, by PMI, for every n contained in the natural numbers, right, we have 1 plus a to the n is bigger than or equal to 1 plus na. And that's our proof.